So we're continuing to find the equation of tangents using calculus. So this time we've got a function that's a little bit harder, not too much harder, but it's a little bit different. X squared plus 2x cubed plus 5x minus 1. And we want to find the equation of the tangent to this curve at x is equal to 3. So again, we need two things. We need our gradient, we need our points. So we've got our x coordinate. So if we get our derivative here, so we derive the function, x squared derives 2x, 2x cubed derives to 6x squared, 5x derives to 5, and minus 1 derives to 0. At x is equal to 3, well, we can get our y coordinate, so that's going to give us, when we substitute 3 into that function, gives us the point 377. And our gradient here is going to be rather large. It's going to be 65. So it's not usual to get really large gradients, but hey, that's possible to happen. So where's our gradient? There's our point, because we substituted our gradient into the gradient, our x value into the gradient function, and was able to get that gradient there. So we put our gradient in, we put our point in, we expand out, we collect our terms, and put our equation in general form. So this time we've got another function, 5x minus 3x squared plus 8, at the point where x is equal to 2. So again, we get our gradient function, so we're deriving this. 5x becomes 5, minus 3x squared gives us minus 6x, plus 8 derives to 0. At x is equal to 2, we get the substitution of 2 back into that equation, gives us 6, so our point is 2, 6. And at x is equal to 2, we get our gradient of minus 7. We just do a substitution there. 5 minus 6 lots of 2 gives us minus 7. Take our values and put it into the equation of the straight line, and then clean it up and get it in general form. This time we've got curve x, y is equal to x cubed, and we've been given our point, so we don't have to work out our y value because it's given to us this time. We still do need our gradient though, because we've got our point, we need our gradient, so we derive x cubed becomes 3x squared. At x is equal to 2, we do our substitution, and we get 3 lots of 2 squared gives us 12. So a gradient of 12, our point of 2, 8. And then expand out and collect our terms and get in general form. We've got a curve here, 2x squared minus 3x plus 5. X is equal to minus 3. Again, derive the function there. And then at x is equal to minus 3, we get our y coordinate. We're subbing it back in there. We sub our x coordinate into the derivative function to get our gradient. So we get our gradient, we've got our point minus 3, 32. And when we sub it in, the x minus 3 gives us x plus 3. Gradient of minus 15, it's y minus 32. Expand out, collect our terms on the one side, and we get our equation. Now, remember the term normal. We've dealt with the normal before. Hopefully remember that normal is perpendicular to a tangent. So if we've got a curve here, and we've got a tangent to the curve, the normal is at right angles to it. So it still goes through the same point. Okay, so if we weren't sure about what a normal is, that's what it is. We get a tangent, and normal is at perpendicular to the tangent through the same point, so 90-degree angle. So how do we find the equation of normal? Well, it's a straight line. We've got our point, we need our gradient. Well, we can get the gradient of the tangent by deriving x squared plus 2 gives us 2x. At x equals 3, that gives us a gradient of 6. Okay, now that's our gradient of our tangent. Okay, so our gradient there of our tangent is 6. Now, the normal is perpendicular to the tangent, which means our gradient of our normal would be the negative reciprocal. Remember, 6 times minus 1 on 6 would equal minus 1. And that's what we need for perpendicular lines. So the equation of our normal, we're still going to use that point 311. So we use that point, but our gradient would be minus 1, 6. The equation, if we were going to find the equation of the tangent, we'd have positive 6 in there. The equation of normal has a gradient of minus 1, 6. So multiply through by 6, multiply here by the minus 1, so that's where we get the minus x plus 3, and then add them on both sides and gives us x plus 6y minus 69 equals 0. So that's what the only thing we've got to do different for the normal is be able to get our gradient of our tangent and then take the negative reciprocal. So this time the normal to this curve, again same procedure. X is equal to 2, so we get our gradient function, and that's going to give us a gradient of our tangent. So we at x is equal to 2 we're able to get our y value by substituting it back into that function. So we get the 0.27. We get our gradient of our tangent by substituting into the gradient function. And then our gradient of the normal would be the negative reciprocal of that, because 20 times minus 1/20th would equal minus 1. We use our gradient there. We've got our 0.27 we're going to sub in, and then we'll clean it up. We'll multiply through by 20, minus x plus minus 2, and then take the x across, and take the 2 across. It gives us the equation of our line there. Question 9, this time we want to get the tangent and the normal at the curve y is equal to x squared. And we're given the point minus 416, so we don't have to work out our point, but we do need to work out our gradient. So the first derivative function, the gradient function, is 2x. So at x is equal to minus 4, the gradient of the tangent would be minus 8, because 2 lots of minus 4 gives us minus 8. We substitute that in for our gradient. Our point is minus 416. And then we'll expand out. So minus 8x minus 32, take them across, gives us the 8x plus y plus 16. The gradient of our normal then would be minus 1 on minus 8. So it gives us the positive 1/8. So that's where our equation of our normal comes in. So we put the same in. We've got the same point. Multiply through by 8 there. And we just got the x plus 4 on that side. Get them all on one side. We get 8x minus 8y plus 132 equals 0. So there we go. There's our how we find a gradient of a tangent and a normal, and then use that to find the equation of either the tangent or the normal. Same process goes through. We need the equation of a line, we need a gradient, we need a point. Points are usually pretty easy to find. This time we've just got another way in our kit bag to find the equation, the gradient of a straight line. We've had plenty of others before. Now we've got another one by using calculus. So make sure we can use that and be able to find the gradient and equation of a tangent and normal.